So right now, firstly, I will talk about our parts of this electrocoagulation reactor. Okay, so as you guys can see, firstly is our EC tank, where we modified this aquarium tank to our project. So the second part is the electrodes, as you guys can see right here, which is the most important for this electrocoagulation process to take place. So as you guys can see, we have measured and we have given gap accordingly to the electrodes so that the electrocoagulation process can take place effectively. All right. So the third part, as you guys can see right here, down here, is the feed water pump. So what is the function of this water pump? So it feed all the treated water of the electrocoagulation process just now, and it runs through the aquarium filter, where it filters down the dirty water or any excess dirty stuff that this water cannot clean, and it runs through the filter and it goes out through the outlet where we get the really clean water. So as you guys can see, this is the most important parts for this electrocoagulation process to happen, because this power ups the water pump, the electrode, and other stuff as well.
Apparently, this machine can transform this pit water into the clear and clean water. What actually happened is the water contains positive charge, and we apply the negative charge through the electrode. It makes the molecule going repel, and this is what it actually looks like. This is a 20 minutes time lapse of electrocoagulation process. And as you can see, the water is slowly going clear. The flow is floating and the sediment is sinking due to the gravity. The clean water was left in the middle and being transferred to aquarium filter using a water pump to remove any excess.
By filling up the tank manually with 7 liters of pit water, the process is simply by just switching the switch. Before turning on the DC power supply, make sure the main switch is selected to process mode. And after the process is running, we will wait for 20 minutes normally. Reverse osmosis process takes 7 until 13 days to finish, so 20 minutes is considerably fast. After the process is done, simply switch to the pump mode in the main switch, and the final product comes out from the outlet and we were done.
Firstly, it is important for us to know how clean and how safe the water is to be consumed or to be used in our daily life, especially to those who live in the rural area of Sarawak, who depends on river water to continue and to live their life. Okay, so now we are going to do a comparison of result that we have obtained with class 1 water that is safe for domestic use, for daily use, and also to do comparison with drinking water quality from the Department of Environment 2018. So the parameters that we are using is pH, turbidity, biochemical oxygen or BOD, dissolved oxygen DO, total suspended solid TSS, and the last one will be total dissolved solid. So we have 6 parameters that we use to check the quality of the water that we have obtained. Now we are going to do comparison for all the parameters, but firstly we're going to do for pH, before treatment, after treatment, and also class 1 and drinking water quality standard comparison. Before treatment, the pH is 5.88. As we can see, it is at acidity side. After treatment, we are able to get 7.6, that is close to neutral 7. And compare 7.6 to class 1 and also the drinking water quality standards, pH that we have obtained is in the class 1 water and also drinking water quality standard. Next is turbidity. Turbidity shows us whether we are able to see through the water or not. That is turbidity. Before treatment, the turbidity is 29, but after treatment, it is 0.5. So compare 0.5 to class 1 water and drinking water quality standards, we are able to get a better value for the water. And the removal efficiency is 98.28%. Now let's talk about BOD, or known as biochemical oxygen demand. So what is it actually? So it is a parameter to measure the amount of oxygen that is needed by the organism or bacteria in the water. Now let's look before treatment. So before treatment, the value is 4, but after 20 minutes treatment, we are able to get 1. Now let's compare it to class 1 and also drinking water quality standards. So for the class 1, we are able to get the same value that is safe for washing clothes for domestic use. But for drinking water, it is still suitable, but for drinking water quality standard, it is preferred to be 0. And the removal efficiency is 96.17%. Next is total suspended solid, meaning to say a solid that we are able to look with our naked eyes in the water. Before treatment, the value is 1390, but after treatment, we are able to get 1. compare it to class 1 and also drinking water parameters, we are able to get lower than drinking water quality water standard. Lastly is total dissolved solid. Total dissolved solid is a solid that we are not able to look with our naked eyes. Meaning to say it is a very small particle or a very small solid that we are not able to see. So the before treatment, the value is 1884. After treatment is 4. Compared to class 1 and also drinking water quality, we are able to get way lower than the value that has been set. And we are safe to say that the water is safe to drink and also safe to use for people.